Okay. So with these, what we're going to want to do is kind of go in the reverse order from what we did in the past. So with these, right? So you're going to take every vertical asymptote. There's a vertical asymptote at x equals 3. This is a vertical asymptote, which means that in your denominator, you're going to have x minus 3.
Okay.
Right? So let's put x minus 3 in the denominator. I don't see a hole anywhere. Do you see a hole in this one?
No.
Now, if there, what is that, a hole right there? I can't really tell.
No, it's a dot. Just a regular dot.
That's a regular dot. And can you tell what it is exactly?
Or that's not even a dot. That's just a pencil mark.
Oh, okay. So this right here is your horizontal asymptote. And what's your horizontal asymptote have to do with? Is that y equals 2?
Yeah.
So that means that there's going to be a 2 on the top, and the degree of the numerator and the denominator are going to be the same.
Okay.
Right?
Yep.
So the degree of the numerator, well, we don't quite have all the rest of it yet, but we know that there's going to be a 0. So here's your 0. Can you tell exactly where that's at? I can't tell. Is that 2.5?
Yeah, it's 2.5.
Okay, so your 0 of 2.5 of x equals 2.5 means that the numerator has that means that in the numerator you have x minus 2.5. Now it's not going to be x minus 2.5. It's going to be, you want to clear that fraction. So 2.5 is what, 5 halves?
Yeah.
So you're gonna have to do a little trick here. Multiply everything, multiply this 2 over to the front. So 2x minus 5. So 2, and actually that helps because we know there has to be a 2 in front, right?
Mm-hmm.
And that 2 in front means that you had 2x minus 5 in front. Okay.
So do you basically just find the vertical, the horizontal, and then whatever x you have?
Yeah. Now, if there's a slant asymptote, which there isn't any, or if there is a hole, there's a little bit more to it, because if there's a hole, you put it on the top and the bottom. Let's say that there was a hole right here, then you put that on the top and the bottom. You put that value on the top and on the bottom, so that would be at 1. So you put x minus 1 at the top and at the bottom.
Okay.
But you don't have a hole, so you're not going to do that. Now, you don't even really have to write the parentheses around this because that's the only thing you have. Now, the last thing you want to do to check to make sure it's right is look at your y-intercept. You see how your y-intercept is at like 1 over 1.5?
Yeah.
So make sure that actually works by plugging in 0 for x. So you would get 5/3, which is just a little over 1.5. So that makes sense. Got it?
Yep.
I'm not going to fill those in. You can do that yourself.
Yeah.
Okay. So for the bottom one, same kind of deal, right? You're looking for, here, let me duplicate this. So I can write on this and not mess up the one I did already. So same kind of deal, right? You're going to take your, do we have any holes in this?
No.
It's kind of hard to tell. But yeah, you're right. It doesn't look like there are. Now, the fact that this approaches the same in both directions, this vertical asymptote, See how it's approaching in the same direction?
Yeah.
That means that your vertical asymptote x equals -1, which means x plus 1 is in the denominator. But because it's approaching in the same direction on the left and right, that means it's going to be squared. The multiplicity is even.
Oh, okay. Yeah. Okay.
You remember that?
Yeah.
So there are no holes.
Mhm.
The Hasse is y equals 0, which means it is,
You don't even need to fill that stuff out. That was just for like extra practice on the
yeah.
thing.
The fact that this is here means that it's going to be bottom heavy, which it already is. So
Mhm.
you don't even have to do anything. There are no x-intercepts. The only other thing you want to do is look at your y-intercept here. See how it's 1?
Yeah.
So you want to put a number up here so that when you plug 0 in here, this whole thing equals 1. So what number would that be?
Like, wait, you want like if I plug in the number to X?
Yeah, you want to put a number up here, just a constant, not a variable. So when you plug in 0 for x, because remember that's how you find your y-intercept, plug in 0 for x,
Yeah.
then you're going to get,
Just
so basically it's just going to be 1.
just one.
Because then when I plug in 0, I get 1 squared, 1 over 1 squared, which is just 1.
Okay.
But then you also want to check it to make sure it's going in the right direction, which it is. It's always going to be positive. It's always going to be above the x-axis. So that's the correct answer.
Okay.
This one says graph the function. So for this, you want to factor, always factor it first. So you've done that. It's
Yeah.
x minus 5 and x plus 1 all over x minus 3. So the x minus 3, that gives you your vertical asymptote. I'll color code this. That gives you your vertical asymptote right there at 3. Right?
Mhm.
These two things give you your do it black. These give you your x-intercepts. So -1 and +5 are your x-intercepts.
Mhm.
Got it? You're going to have a slant asymptote because it's top heavy, because the top is more than the bottom. You're going to have a
Mhm.
slant asymptote. So you're going to do long division. Have you done this yet? X squared minus 4x minus 5. You do long division. That's how you find your slant asymptote.
Okay.
So long division gives you your slant asymptote. This goes into x squared x times, multiply it and put it here. So it's x squared minus 3x, and you're subtracting that whole thing. So the signs change.
Yeah.
Right? So this is -x minus 5. And how many times does this go into this? Divide it. What do you get? -1.
-1.
And that's your SLACI. X minus 1 is your slant asymptote.
Okay.
So x minus 1 is here. And then that's your y-intercept, -1. Remember graphing? And then the slope is 1. So it's going to go like this.
Mhm.
Do you get that?
Yep.
That's your SLACI. And so now let's just look at the value. Oh, let's find our y-intercept now. The y-intercept is going to be this, -5 over -3, which is 5/3. Remember, you plug in the zeros for all your x's. So 5/3 is 1 and 2/3. It's going to be up here, which kind of makes sense because your graph is going to go like this. It's going to approach there, and it's going to approach here. And on this side, it's going to go approach there and approach there.
Okay.
Got it?
Yeah.
All right, I'll let you fill in all that other stuff. I'll just jump to the next one and give you one last one. All right, graph the following function. So I'm gonna do this quick. So let's factor the top and bottom. This is gonna be x plus 4 and x minus 3. And this is gonna be x plus 4, x minus 4.
Mhm.
So these cancel out. That means you have a hole. You have a hole at -4, comma, whatever you get when you plug -4 into this here and here.
Yeah.
-4 into here gives you -7 over -8. -7 over -8 is +7/8. So we have a hole at -4 and +7/8 right about there. Draw your hole in there.
Yep.
Okay. The vertical asymptote is going to be where the denominator equals 0. So it's x equals 4. So draw in x equals 4. Draw in your VASI. The horizontal asymptote is at 1. Because the degrees are the same, so you take your leading coefficients, which is just 1 over 1.
Mhm.
Since the degrees are the same, you just take your leading coefficients. So your HASI is x equals 1. Your SLASI, you don't have any. Your x-intercepts, you look at the numerator where it equals 0, which is at 3. So 3 comma 0. Your y-intercept, plug in 0 for x, you get -3/4 or, sorry, -3 over -4 or 3/4. Got it? So let's put those points in. There's your y-intercept, 3/4. There's your, I'm sorry, your x-intercept. There's your y-intercept. And then you can see what the graph is going to do. It has to go this way
Yeah.
because of the points that you have. And it's going to have to go this way. Otherwise, you'd have more x-intercepts if it was down below here.
Mhm.
Right? And see how they don't go the same. They approach it in opposite directions because the multiplicity of that is 1.
Okay.
Okay. All right. Perfect timing.
All right. Thank you.
Hey, no problem, bud. Good to see you again. And check out this video online if you need to. It's